It's Stereo Police. Welcome back to part 2 of Lecture 5, Lecture 5.5. Today we're going to look at some actual real distortion from a vacuum tube amp created across a pair of dummy loads. And what we're going to do is turn up the volume and find out what happens to the sine wave when distortion occurs, what it looks like. We're going to look at the FFT and look at the harmonics that are created as a result of it, and then compare what happens with a THD reading off of a calibrated total harmonic distortion meter. So just to get an intuitive feel for what's actually going on with respect to THD. And before I do that, I just want to cover two different slides here. Both of these taken from a Stereophile review. All right, so distortion can be looked at in a few different ways. THD, that is, total harmonic distortion. And one way, or one specification that's handy to look at is how total harmonic distortion changes with respect to power. And one of the typical measurements for that is we will put in a sine wave, and in this case, it happens to be 1 kilohertz, I believe. It's a typical value used. I don't think it says it right here, but and we'll feed that into the amplifier, and we'll put that across across an 8 ohm. In this case, an 8 ohm dummy load, power resistor likely, and then we're going to take some readings, okay? And what we're going to do is we're going to increase the power in this direction, and then we're going to read THD and watch, and that's what this red trace is right here, this red line. We're going to watch how THD, total harmonic distortion, changes with respect to power as power increases. And in this case, as you can see, it remains pretty low. 1% is right here, and 1% is considered inaudible by most people. You want to definitely almost always have THD below 1%. And you can see is we're very, very low here, and until we reach a certain point, and this is called the knee, and of the curve, any curve, you know, the knee of the curve where it starts to abruptly change. And at this point right here, usually with a solid state amp, this is where clipping begins. And the term clipping is when the sine wave starts to distort like that and become more of a flat top. It clips like a flat top haircut. And when that happens, you know, like we talked about, in order to synthesize this wave, we have to add harmonics to it. And those harmonics come in the form of, you know, second, third, fourth harmonics, etc., at different levels to contribute. And those are distortion. And we're going to look at that today. But at this point, we have a rapid rise here between 50 and 60, 70. Right there at about 70 watts, we start rising, and this will continue to go up dramatically. Into 8 ohms, we start rising. So about 1%, if you want to choose a standard of 1%, and I don't think it's a well agreed upon standard. But if you want to choose a standard of 1%, this would be about this amp would be about 70 watts. Some amplifier companies will be more conservative, and they'll just pick a value down here, you know, and they'll leave a little bit of headroom. All right, another way to look at it, THD, is here we put in a fixed sine wave at a fixed frequency, for example, 1 kilohertz. And we looked at how THD changed with power. You know, and we reach a point where the amp can no longer sink the current, and THD rapidly increases. Another way to look at it, THD also changes with frequency. So we can basically hold the power steady. And in this point, they've held it steady at about 10 watts, which is well within the envelope of the capabilities of this amp. So we're not pushing the amp. So they're, and that's 8.95, roughly 10 volts into 8 ohms. So that would be 10 squared, 80 divided by 8 for power output, 10 watts. And then we can look at how THD changes, and that's the left and right channels down here. And this particular amp, the left and right channels track each other pretty good. And we can see how THD changes with frequency, and you can see at low frequencies, 20, 50, 100, we start, it's very low. Where's our 1%? Our 1% threshold as well. So this amp stays well below 1%. But as you can see, THD, in this particular case, increases with frequency, and we get to the point where we're at, I don't consider 20 hertz the top of the audio. No one can hear, nobody, no human, very few can hear that high. Maybe a 5-year-old. So I think more suitably somewhere around 15, 15 or so K. But anyway, we can see it rises to that point, 0.05%. From all the way down here from 0.002%. So you have to be careful how amps are spec'd out. Amplifiers are spec'd out at, for example, a lot of times 1 kilohertz. And the THD is going to be much lower there. It's going to be higher at higher frequencies, some cases higher at lower frequencies, and this kind of plot might reveal some kind of flaw. So there are uses for this sort of thing. All right, let's get on the rest of this video. You're going to be watching me on my workbench, showing you various interesting ways of looking at actual real THD. And at the very end of this video, it's going to pretty much come to an abrupt halt because I was finished and I didn't have any closing remarks. So enjoy. Thank you all for watching. Stereo Police. Hey, it's Stereo Police. Let's look at some actual THD. And what you're looking at here in blue is a 1 kilohertz input sine wave from this audio frequency generator that's being input to this very, very low wattage 300B based vacuum tube amplifier. It's being input to the CD inputs. And I'll be amplifying it out of one of these two 300Bs. The reason I wanted a low powered amplifier is I just want to use a couple of dummy loads, a couple of resistors in place of speakers because I don't want to hear the noise. And then we're going to look at the output signal and we're going to distort it and look at THD and kind of determine, at what point distortion starts to occur using several different criteria, 3 of them at least. So you're looking at the input signal, the amp is on, and I'm going to start turning up the volume. Okay. The yellow trace is the output on top, and that's what's coming out of the speakers. At least one speaker we're looking at. And the blue trace is the input. So right now, and I'm just going to go ahead and turn the blue off because that's never going to change. We're not going to change the input level at all. All right. So let's just take a moment and view this sine wave. This is a very good low distortion audio generator that I'm using, so this should be a low distortion sine wave, and I'm controlling the volume knob on the amplifier all the way down. Let's just pick some value right there, and a little higher. And you can see at the very bottom RMS. Those are the RMS volts. So let's go to about 500 millivolts. So that's 0.5 volts. Let's find out how much power is being dissipated across this dummy load right here. So that's 0.5. Power is V squared over R times 0.5 divided by 8. And it's just 0.03 watts. Or 30 milliwatts. Very little. Let's turn the volume up a little bit. Now we're at about 2 volts RMS across the load. So 2 times 2 is 4 divided by 8. That's 1/2 of a watt. Now I can tell you this amp starts distorting very, very early. It's a very low power amp. So let's take a look at distortion 3 different ways. First of all, just flat out visually. You see if you can see that? Okay. All right. So we're looking at the output. I'm going to start increasing the voltage. Now take a look at this sine wave. And let's just visually determine when it no longer starts looking like a normal sine wave. And I'll do it with you. It's starting to look a little weird right there. That's not normal. It's getting flat on the top, funky on the bottom. I'm backing it down till it starts to look like a normal sine wave again, and we're kind of there right there. The RMS volts is 4.37. So 4.37 times 4.37 equals, and divided by 8. So that's 2.4 watts. Determining visually, when just looking at the sine wave, that when distortion starts to occur. Now let's do this. I have a total harmonic distortion meter running right now, and just knowing that, let's see what the THD meter says. We're at 4.4% THD. And I'm going to, while you're watching this, I'm going to turn the volume down just a little bit to make it even a better sine wave. And we're back down to 1.7%. It's about as good as it gets with this amp. All right. So visually, we start to see distortion at about 2.4 watts. Interesting. Now let's look at the fast Fourier transform. Let's go to the frequency domain. All right. So I'm rotating the volume knob. It's pretty low right now, and that big spike you see right here is our fundamental. I could get some cursors here and measure it, but no need to. What did I say frequency we're putting in? We're actually at 100 hertz. I apologize. I said 1 kilohertz. We're at 100 hertz. And it does say it right down here, 99.7 hertz. We're at 100 hertz. Okay, now I'm going to start rotating the volume knob up, and let's watch some of these fundamentals start to rise. I mean, some of the harmonics start to rise. So our second, our third, fourth, it's really distorting now. So that's our distortion. At this point, let's bounce over and see what the, I'm going to leave it right here, and let's bounce over and see what the sine wave looks like. Pretty bad. Let me bounce over to the FFT. Okay. Now I'm going to rotate the volume down to eradicate the harmonics, just to the point where they disappear. And I'll tell you what, let's leave that second harmonic right there. Let's leave them alone, and let's bounce over and see what the waveform looks like. Pretty good. Pretty good. I wouldn't be able to tell. So at this point, with that little second harmonic peaking up, what do we have THD wise? 2%. All right. Let's go back to our FFT. And start creating some more distortion. Let's bring up at least the second, third, and fourth harmonics. Let's go see what the waveform looks like. Pretty bad. I'm starting to see that lump on, see that lump on the top. We're now at 7%. Now let's make it a little worse. Okay, here we go. That's bad. Look at all those harmonics. Let's bounce over to the waveform. That's bad. That's clipping. %, THD. I'm going to turn it down. So let's back it down. For example, actually, let's do this. Even at a fairly low signal, let me okay, this is that signal that's 0.03 watts right here. So just barely audible probably. This amp, we're at 0.3 THD. Now let's just, I'm going to continue turning the volume up until we reach 1%. And there it is. Let's go over here and find out what's going on at 1%. Looks pretty good. Let's do an FFT. And tighten that up a little bit. You can see we have a bit of a, and this is a logarithmic scale, this isn't an absolute scale, so these are actually way down lower than they appear to be relative to the fundamental. So you can see we have a bit of a second harmonic peaking up and a bit of a third harmonic at 1%. And this is all happening, so this 1% just started appearing at how much power output? Well, we're at 1.7, so let's call it 1.8 volts RPMs. So that's 1.8 times 1.8 divided by 8, and that's half a watt. 0.5 watts. Now, that's where we are now. Now what I'm going to do is I'm going to continue turning the volume up until we start to see this 1% really start to rise, take off. That's the knee of the THD curve. We're still not that bad. Oh, now it's starting to really, now it's really starting to take off right there. So we're at 3%. Let me see if I can really get it to 4, 5, 6, 7. Oh yeah, there's the knee right there. So it's really starting to take off right there at about 3.6%. So let's see what's going on here. Well, yeah, our sine wave looks maybe a little, barely visible. Maybe it's a little pinch down here. I don't know. It's barely visible. Let's look at the FFT. Yep. So right there, when things are beginning to take off, that's when the second, third, fourth harmonics really starting to rise. Now I'm going to take the volume knob and turn it up slowly as if I'm increasing the volume, and you'll watch these things really, see that? They're really going up now. And that's the knee of the THD curve, where it really starts, where the THD really starts taking off. Okay.